All right, let's just jump right into this explainer. Today, we're going to use the clues hidden out there in the cosmos to solve one of the most profound mysteries imaginable. We'll be looking at the very shape, size, and origin of absolutely everything there is. And we're going to do it all just by looking up.
So why exactly is the night sky dark? I know, it sounds like a question a 5-year-old might ask. But believe it or not, this simple, everyday observation totally stumped some of history's absolute greatest scientific minds for centuries. To really understand why it's such a massive puzzle, we have to take a little trip back in time. The mystery really kicks off in the 16th century. For the longest time, people just assumed Earth was sitting inside this fixed, thin shell of rotating stars. But then a guy named Thomas Digges completely shattered that idea. He proposed something truly radical, an infinite, completely static universe packed with endless stars going on forever in every single direction. It's a gorgeous thought, right? But mathematically, it birthed an absolute nightmare of a problem.
And that nightmare became famously known as Olbers' paradox. Think about the pure logic of it for a second. If space is truly infinite and it contains an infinite number of stars, then no matter where you look up in the night sky, your line of sight literally has to hit a star eventually. Every single patch of black should be filled by a star at some distance, which means the entire sky should be a blazing, blinding sheet of light, literally as bright as the sun. But obviously you look out your window tonight and it's dark. So what on earth are we missing?
Part 1. The shape of the crime scene. To crack this paradox, the very first clue means we have to completely reevaluate reality itself. We've got to stop thinking of space as this boring, flat, empty box. See, for over 2,000 years, humanity heavily relied on Euclid's flat geometry, the whole rule that parallel lines never meet. But then, the mathematician Carl Friedrich Gauss came along and realized those rules aren't actually absolute. He proposed that space itself could actually be curved. Gauss proved this curvature with what he called his remarkable theorem. And the crazy part is, you don't even have to leave a surface to tell if it's curved. Imagine a little ant following these exact steps. Step 1, it starts at the North Pole facing perfectly south. Step 2, it shuffles sideways along the equator. Step 3, it walks straight backward, right up to the pole. When our little ant arrives back exactly where it started, it's suddenly facing a completely different direction. That brilliantly proves it's on a curved surface, without ever having to float up into space to check.
Part 2, Redefining Groggy.
So a brilliant student named Bernhard Riemann took Gauss's work and pushed it into 3 dimensions, which perfectly set the stage for Albert Einstein. Before Einstein, ever since Newton, we thought of gravity as this invisible pulling force, kind of like a rubber band snapping planets together. But Einstein's general relativity completely flipped the script. He proved gravity isn't a pulling force at all. Think of placing a really heavy bowling ball on a trampoline. It sinks down, right? And it curves the fabric around it. That is exactly what mass physically does to the dynamic fabric of space. So when an apple falls from a tree, it's really just following the absolute easiest path down the curve created by the Earth.
Part 3. The expanding fabric.
This massive realization that space is a malleable, almost living entity that reacts to matter was exactly the breakthrough we needed to solve our dark sky mystery. But when Einstein applied his own math to the entire cosmos, the equations spat out a description that seemed completely ridiculous, even to him. They were describing a universe that was actively expanding. It was so outlandish to human common sense at the time that Einstein actually altered his own equations to hide it and keep the math perfectly still. But you can't hide the truth forever. Using the stellar distance measuring techniques developed by the brilliantly unsung scientist Henrietta Lacks, an astronomer named Edwin Hubble made a monumental discovery. He proved that distant galaxies are redshifted. Now, in physics, when you see stretched out red light waves, it is definitive, undeniable proof that whatever you're looking at is actively moving away from you. Now, let's be super clear about what this means, because it is absolutely vital. These galaxies are not just flying apart from each other through some pre-existing empty room. The actual fabric of space in between them is expanding. It's getting bigger. The whole universe is stretching. Einstein actually visited Hubble later, saw the data for himself, and freely admitted that changing his equations to hide that expansion was the biggest scientific blunder of his life.
Part 4, Rewinding the Clock.
Okay, so if space is expanding right now, basic logic tells us that in the past, everything had to be much closer together. If you trace that exact rate of expansion backward, it points directly to a Big Bang creation moment. And guys, this isn't just some wild theory. The fossilized microwave light from that fiery dawn is quite literally still washing over Earth today. It's actually what used to get picked up as that fuzzy static on old rabbit ear televisions. By measuring that exact relic radiation, cosmologists were able to lock in the absolute finite age of our entire universe, 13.7 billion years. Part 5. Solving the Paradox. And here is where all those puzzle pieces finally click together to solve Olber's paradox. Remember, the universe hasn't just existed forever. We know it has a finite age of 13.7 billion years. Plus, general relativity showed us that space itself is constantly expanding. So, a beam of light from the absolute most distant edge of the cosmos is desperately trying to cross an ever-expanding distance. And because the universe just isn't infinitely old, the light from those furthest stars simply hasn't had enough time to reach our eyes yet.
Because light takes time to travel, we are strictly limited to seeing only the observable universe. That's just the specific local bubble where light actually has had enough time to reach us since the Big Bang. And within that visible boundary, there simply are not enough stars to light up the whole sky. So that beautiful dark night sky you see is quite literally the visual proof that our universe had a beginning.
Part 6. A darker future. So we've officially solved the mystery of why the sky is dark today. But the story of our universe actually has one final kind of unsettling twist about the future. Back in 1988, astronomers studying distant supernovas completely expected to find that the universe's expansion was slowing down, naturally hitting the brakes because of gravity. But instead, they got a massive shock. A mysterious force, what we now call dark energy, is actively accelerating the expansion. The universe isn't just getting bigger, it's getting bigger faster. As space stretches faster and faster, there's going to come a terrifying time, billions of years from now, when the expansion actually outpaces light itself. And when that happens, light from other galaxies will no longer be able to outrun the expansion to reach us. Those distant galaxies will literally just fade away and disappear from view forever. It's going to leave our future night sky incredibly desolate, with only the stars of our own local Milky Way left to look at.
When the sky is ultimately emptied of all that distant light, it leaves us with this really profound final thought about reality itself. Think about it. If you have a box and you take out the stars, the galaxies, the light, absolutely everything, what exactly exists inside the empty space in that box? Is it really just nothing? Or is space itself the ultimate, ever-changing cosmic mystery?